Hi, junior scientist. We're going to be discussing 3 types of energy today. The energy of heat, electrical energy, and light energy. So let's start with heat energy. Heat is energy that moves between objects of different temperatures. The difference in temperature makes the energy move. So what are the ways that heat can move? Well, the first way is through conduction. Conduction is the actual transfer or movement of heat between 2 objects that are touching. So you see this hand is touching the snowball. The heat from the hand transfers to the snowball, causing the snowball to start melting. And then your hand feels cold from the snowball. Here you have warm soup, and because the spoon is touching the warm soup, it's going to go ahead and transfer its heat to the handle of the spoon because they're touching. That's conduction. So let me show you an example here. Here's an ice cube. I'm going to go ahead and take the ice cube and put it in my hand. The heat from my hand is going to start to melt the ice cube. You might notice this when you have chocolate in your hand and all of a sudden your chocolate starts melting. That's from the heat that's coming from your hand. Your body's pretty warm. See the liquid? See the ice melting? You can actually see it dripping from my hand. See that? That's through conduction, where they actually touch each other and heat's transferred. I'm also going to show you this through the stove here. This stove is cool. I don't have to actually touch it. I can hover my hand over it and feel that it's cool. But I'm going to change that. I'm going to turn it on, and you're going to see it heat up. Now, the side of this pot is also cool, and the water inside is also cool. But now that's hot. See how red it is? So through conduction, these 2 are touching. You're going to see the transfer of heat from the stove to the cool pot until the pot is no longer cool. It's going to turn warm and then hot. That's conduction, when 2 things are touching. Now, this water in here is cool. However, it's not going to be cool for much longer because when this heat transfers to the pot's going to get hot, and then it's going to transfer the heat to the water. So the water is going to get hot. Any of the water that's hot will rise to the top. Cool water will sink, and then it'll get warm and then rise, and then if there's any cool water left, it'll sink, get warm, and it'll keep repeating itself until the water is all hot. So I'm going to go ahead and cover this, and we'll come back and check on that later. Another form of heat transferring is radiant heat or radiation. And that's when heat travels through empty space. So it's kind of like when you go outside and you feel the sun on your skin. That's the sun radiating. So I'm going to use this example here of this candle as radiant heat. I'm going to light it. And you can just hover your hand over it, and it's pretty hot. You don't have to touch it. That's heat radiating through empty space. That's radiation. So let's show another way heat works. We're going to do this popcorn maker here. And we're also going to introduce another form of energy, electrical energy. And electrical energy is energy that travels through wires. Now I can touch this because it's rubber. See that? And the wires are safe inside so that I can touch this. So this rubber is going to allow me to touch it and not get hurt. It's called an insulator. Now this is going to be loud, so get ready. I'm going to plug it in. And I know the electricity is flowing through the wires because I hear the machine turn on. Now right now it's cool, but it's going to start to get warm. So what I'm going to do is I'm going to get this cool popcorn and I'm going to pour it in. I'm going to put this lid on. You can also see the cool butter. It's a solid. And that's going to turn into a liquid as it heats up. And these kernels are going to turn into popcorn kernels that you can eat once it gets hot enough. So you're going to see two things going on. You're going to see the popcorn kernels pop because of the heat, and you're going to see the butter melt because of the heat. Now, if you're very observant, you'll see two other forms of energy that we've already learned about. Sound energy, you hear it? And the energy of motion. See everything moving? So now we're going to wait until we see the popcorn get hot enough where it actually pops. Those didn't pop, but we're going to start seeing some. There you go. They're starting to get hot now, so they're starting to pop. Is the butter melting? Yep, it's starting to melt. See the liquid in there? So you got electrical energy flowing through the wires, heating this up, causing heat in here, hot air, to make the popcorn kernels pop and the butter melt. There you go. Now let's go back to our water. If you listen carefully, you'll hear that there's something going on with that water in there. So we're going to carefully lift it. Now again, I'm okay lifting this because this is made out of plastic. And that's going to protect my hands from the heat. And now we start to see the steam coming up. So we know that it's actually doing its job. The water's getting hot. You can see the steam rising from it. Now if I go ahead and I put this plastic spoon in here, will the heat from the water transfer up? The answer is no, because this plastic spoon is an insulator, just like the plug that I just showed you. Here's a wooden spoon. If I put that in, will the heat from the water transfer up to here? No. The answer is no, again, because it's made out of wood. It's not a conductor of heat or electricity for that matter. When I put this metal spoon in here, will the heated water transfer the heat up? Yes. The answer is that one will be hot because it's made out of metal. So that makes this a conductor, and it makes these two insulators. All right, now we're going to go on to another appliance, the toaster. And again, we're going to use electrical energy to start it. We're going to put our bread in here. And if you look inside, you can see what's happening. See the coils? So the coils are getting hot. And the coils in this toaster heat the air, which heats the toast and toasts it. So the toast is a result of convection. Remember, convection is when heat transfers between liquids and gases. So those coils are actually heating the air, which heats the toast. They're not actually touching the toast. So we'll wait for it to pop up in a minute. While we wait for that, you can see that electrical energy is used for different appliances, like that blender that chops and dices and blends, and the popcorn maker that we just saw, the toaster oven, the stove, the oven, and you can even see this lava lamp using electrical energy, and this light bulb that we'll talk about in just a minute, as well as my computers. I heard the toast, so we're going to go back here, and you can see that the coils, without actually touching the toast, heated the air and toasted the bread. So let's go on to light energy now. Light energy is simply energy that you can see. So here you can see the light, and if you feel it, you can actually feel the heat coming from the lava lamp also. Now the lava lamp uses electrical energy. You can see here that I can turn it on or off. And that produces light and heat. We're going to also do this other little experiment here using electrical energy. Again, electrical energy is energy that flows through wires. You're going to plug it in, and you can see that the bulb goes on. That's light energy, energy that you can see. Now, this light bulb not only gives off light energy, but it also gives off heat energy. If you just hover your hand right above it, you'll feel the heat from the bulb. So it also gives off light and heat energy. Now this little experiment here is showing that heat rises. So the heat here is rising, you can feel it. And what it's going to do, it's going to go up, and it's actually going to turn this spiral ever so gently. It kind of looks like wind is blowing it, but it's not. It's the heat rising from the bulb. That's kind of like what makes a hot air balloon work. Heat rises and causes movement. It doesn't move too much, but it moves just a little bit. I don't know if you can actually see it or not. Just a slight movement where it looks like somebody might be actually blowing on it. But it's coming from the heat rising from the bulb. Okay, junior scientist. So remember, heat moves from a warmer to a cooler object. It moves through conduction, where two things are actually touching each other. It moves through convection. That could involve liquids or gases. And it moves through radiation, through empty space, where you can feel the heat through empty space. Electrical energy is energy that travels through wires. And light energy is energy that you can actually see. And don't forget sound energy that we just did. You can hear it from vibrations. And the energy of motion, where there's actual movement. And there's a lot of energy of motion going on here with the water. You can see it. And don't forget, if it's a conductor of electricity, that means it flows through the wires. It goes through the metal. If it's an insulator, it protects you against electricity It protects you against the heat. Like this plastic or wooden spoon. Also rubber spoons do the same thing. All right. I'll see you later.